Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. Today we are going to discuss the following things. One is types of modulation and second one is analog modulation techniques. So, what is the modulation? The modulation is defined as the high frequency carrier signal is varied according to instantaneous values of the message signal. Here we discuss the two signals. One is high frequency carrier signal, second one is message signal. Nothing but the message signal is a low frequency signal, the carrier signal is a high frequency signal. So, the modulation is defined as the process of the high frequency carrier signal is varied according to instantaneous values of the message signal, that is called as a modulation process. So, the representation of the message signal and carrier signal in graphical form. Observe, first I drawn the message signal. This is the representation of the message signal. In x-axis the time period t and y-axis amplitude. This is the message signal, that's why I am taking m of t. Then I go for the next signal, the carrier. The representation of the carrier signal is like this. In x-axis time period and y-axis amplitude. So, what is the fundamental difference when observing these two graphs is the time period is less for the first one. Remember, here the time period is less in the carrier signal, here the time period is more. We know the relation, the frequency is inversely proportional to time period. The time period is more means the frequency is less. The time period is less means the frequency is more. Therefore, based on that one, high frequency signal representation is like this and the low frequency signal representation is like this. So, as per the definition of the message modulation process, the high frequency carrier signal is varied according to instantaneous values of the message signal. Nothing but, observe here, the high frequency signal does not consist any information, but the message signal consists the information. Therefore, you need to transmit the message signal to a long distance or reduce the noise. For that purposes, we use the supported signal as a high frequency, that is the carrier signal as a high frequency signal. That means the carrier does not contains any information, but it provides a boosting or support to the message signal. When you combine both the signals, the process is called as a modulation process. So, we need these two signals, but remember, our information consists the low frequency signal, nothing but a message signal, and need a supporting signal, that is the high frequency signal, that is a carrier signal. Based on this knowledge, what are the categorization of the modulation or types of modulation? Basically, the types of modulation can be categorized into two types. One is continuous wave modulation and the second one is pulse modulation techniques. We know continuous wave modulation means the wave continuously varying with respect to time, that is called as a continuous wave. Does not varying continuously, that is called as a digital or a pulse modulation techniques. So, in the first lesson we discussed about the amplitude modulation and angle modulation. Remember, when you learn, first of all, the wave characteristics, mainly based on the wave having the three characteristics. For example, I am taking the sinusoidal wave. In x-axis, it is the time period. Once you know the time period, automatically you know the frequency also. That is the one property. The next one is amplitude, nothing but how much amplitude having. For example, like a 2 volts or 1.2 volts, like that. So one is frequency is one parameter, amplitude is another parameter, and third one is phase. That means any wave having these three parameters. What are those? Frequency, second one is phase, and third one is amplitude. Based on this one, we are defining the modulation under the continuous process. What are those? Amplitude modulation, and the second one is angle modulation. So again, angle modulation can be categorized into two types. One is frequency modulation and the second one is phase modulation. Observe, these all the techniques should be under continuous wave modulation. What is the meaning of continuous wave modulation? Means the information signal is in the form of a continuous, and the supported signal, nothing but a carrier signal, is also in the form of a continuous. Nothing but the low frequency signal, it is nothing but a message signal, it is a continuous in nature. Second one is carrier signal, it is a high frequency signal, it is also continuous in nature. Therefore, in the amplitude modulation or in angle modulation, both the signals, nothing but message signal and carrier signal, both are in continuous. That's why it is called as a continuous wave modulation. We discuss one by one. First of all, what is the types of analog modulation techniques? What are the types of analog modulation techniques? Observe here, what are the types of analog modulation? Continuous wave, it is also called as analog wave. What are the different modulation techniques? Observe, this is the first one, amplitude modulation. Second one, frequency modulation. And third one is phase modulation. These three under analog modulation techniques. Therefore, one by one, what is the definition of the amplitude modulation, frequency and phase modulation? We already known the wave, the sinusoidal wave or any wave having the maximum these three characteristics: amplitude, frequency and phase. First of all, once you define the amplitude modulation, we have an idea, the fundamental definition of the modulation process. What is the fundamental definition of the modulation? Again, I repeat, the modulation process is nothing but the process of high frequency carrier signal. The process of high frequency carrier signal is varied according to instantaneous values of, remember here I am using the word instantaneous values. What are the instantaneous values? The instantaneous values are nothing but amplitude, frequency and phase. Amplitude, frequency and phase. Therefore, once I define the amplitude instantaneous value means nothing but amplitude modulation. What is the definition? Observe. Modulation definition you know. Then what is the definition of amplitude modulation? The amplitude of the carrier signal. The amplitude of the carrier signal is varied accordance with the instantaneous values of the modulating signal. Remember, the modulating signal is nothing but it is also called as a message signal, information signal, nothing but M of t. I am representing mathematically M of t. So, what is the amplitude modulation? The amplitude of the carrier signal. Observe here, the amplitude of the carrier signal is varied. Only M vary. Amplitude of the carrier signal is varied according to instantaneous values of the message signal. That is called as a amplitude modulation. Observe here the diagram for the amplitude modulation. Here first I am taking the modulating signal. This modulating signal is also called as information signal or a message signal. Then observe the carrier signal, this is M of t, and this is C of t. The carrier, just observe the modulating information signal shape and the carrier signal shape. Then observe here, once you can take the time period, for example, if you consider this is the time period. The time period is, observe here, very high means the frequency is less. Our information signal is a low frequency signal. The low frequency signal is also called as a modulating signal. Then observe the carrier signal. The carrier signal, observe here, the time period is very less. The time period is very less means the frequency is more. The frequency is more means this type of high frequency signals are called as a carrier signal. As we know the definition of the modulation, the high frequency carrier signal, nothing but C of t, is varied according to message signal, according to instantaneous value. Here the instantaneous value, first one is amplitude. That's why the definition clearly explains the amplitude modulation is defined as the amplitude of the carrier signal. Remember, amplitude means this is the amplitude. The amplitude of the carrier signal is varied. Observe, the amplitude of the carrier signal is varied accordance with the instantaneous values of the modulating. Here the instantaneous values means only amplitude of the carrier, amplitude of the carrier signal. Therefore, observe here, these amplitudes, the carrier amplitudes are varying with respect to message signal. That is the meaning. Like this. Therefore, the amplitudes of the carrier signal is varied according to the instantaneous values means amplitude values of the message signal. The amplitude values of the message signal means these are the amplitude values of the message signals. Like this. Observe here, the internal wave is carrier. This carrier is, the red color should be here, observe. This thick line red color is message signal. The blue color should be indicating as a carrier. That means the carrier amplitudes are varying with respect to amplitudes of the message signal. That's why this is called as a amplitude modulation. This is called as a amplitude modulation. Observe the previous one. What is the definition? Amplitude of the carrier is varied in accordance with the instantaneous values of the modulating signal. That is called as a amplitude modulation. The following diagram is indicating this is the message signal M of t and this is the carrier signal C of t, and this is, for example, S of t is equal to the carrier amplitude is varying with respect to message signal. This is nothing but a amplitude modulation. Amplitude modulation. This is under continuous wave modulation technique. Then go for the next one. Next instantaneous values is frequency. The first instantaneous value amplitude. The next instantaneous value as per following frequency. Then just replace the amplitude word with the frequency, then the definition is over. Then what is that? The frequency modulation. The frequency of the carrier is varied. The frequency of the carrier is varied in accordance with the instantaneous values of the modulating signal. Accordance with the instantaneous values of the modulating. Here the instantaneous value is nothing but the message signal frequency. That means just replacing the word amplitude with the frequency, then the definition is same as amplitude modulation, known frequency modulation. Again I repeat, the frequency modulation is defined as the frequency of the carrier is varied in accordance with the instantaneous values of the modulating signal. Then observe the waveform representation of the frequency modulation. Observe here, the first one is I am taking the modulating signal. It is also called as information signal. It is a low frequency signal M of t. Then the second one is carrier waveform. Observe here, this is the carrier signal. It is a high frequency signal. It does not contains or consists any information. Just it was helpful to processing the message signal information to a long distance or passing to the transmitted to the receiver. Therefore, it is a high frequency signal. I am taking this is the C of t. Then observe here the frequency modulation. What is that? The frequency modulation definition. Frequency of the carrier is. What is the meaning of the frequency of the carrier? Observe the time period in x-axis. Once you know the time period means automatically you know the frequency. Then you need to look in x-axis. Nothing but in, observe here in this direction. Not we are concentrating on amplitude. We are concentrating on the time period. Nothing but we are concentrating on the frequency. That means the frequency of the carrier signal is varied according to instantaneous values of the frequency values of the message signal. Observe here, it start with the 0, it is increasing. It start with the 0 position, it is increasing and it is high peak level and it should be fall down and again it reaches to 0. That's why observe here at 0 position, nothing but when it starts to 0 and a low frequency, that's why up to this one it should be, for example, this position. After that it is a high value here, then the number of cycles should be more and very close to each other. Very close to each other means the time period is less means it is a high frequency signal. The time period is less means the frequency is more. The frequency is more. And then observe here again this is the low value, the negative peak. Then observe the gap here, observe from this point to this point the gap is very nothing but this point. Then from that point to next level this is having a very big value, very big negative value, very low frequency value. That's why here the time gap here is more. Again having the positive peak here, then I am observing the high frequency responses, low time period. Here also I am observing the high frequency responses, low time period. But here it is the negative value, it is a, observe here having the time gap is more. That means only the frequency is varying. The carrier frequency is varying with respect to the message signal variation. The message signal time period or frequency variation. That's why the definition is called as a frequency modulation. The frequency of the carrier signal is varied according to the frequency levels of the message signal. That is called as a frequency modulation. This waveform represents, observe here, this is the high value of the frequency and this is the low value of the frequency. Again this is the high value of the frequency. The frequency shifting from high value to low value to high value. The shifting is happens means low to high, high to high, high to low. The modulation is happens. That is the meaning. That's why it is called as a frequency modulation. Then observe the definition of the frequency modulation. The frequency of the carrier is varied in accordance with the frequency values of the modulating signal. The instantaneous value is the frequency. That's why it is called as a frequency modulation. And the third one is phase modulation. The frequency modulation is also under the continuous wave modulation scheme. The next one is phase modulation. Just replace the word amplitude or frequency with phase. Then observe here, phase of the carrier signal is varied in accordance with the instantaneous values of modulating signal. The instantaneous values of modulating signal. That is called as a phase modulation. Again I repeat, the phase of the carrier is varied in accordance with the instantaneous values of modulating signal. Observe the waveform of the phase. Remember here, the phase modulation I am taking here, this is the modulating signal and this is the carrier signal. This is the modulating signal, we know very well, information signal, and this is the carrier signal. It is a high frequency signal. That's why the time period should be very less between the time cycles of the sine wave. And here this is the message signal, our information signal, having the time gap is more. That's why it is the low frequency signal. Then observe here, phase modulation is varying. That means here it is starting from this point, it is the positive peak, but here the phase reversal occurs. That's why it starts with the negative and it should be high position and having the phase should be very narrow. That's why it's going like this. and it can varying, for example, with respect to message signal phases. Therefore, it should be varying time gap is like this. Again here the phases with respect to phase 0 to high value, and when you reducing a high value to 0, then the phase reversal is happens. Observe here, it is positive side, but it is starting with the negative side. The phase is happens. That's why, as per the definition, observe the phase of the carrier. Nothing but here, this is the phase. For example, it starts with the positive 0, positive side. But here, observe the modulated signal. The modulated signal is nothing but after combining message signal and carrier signal, the released signal is called as a modulated signal. Then what happens here? It starts from negative side. Therefore, phase reversal is happen. That's why the phase is varying with respect to phase of the modulating signal. That's why it is called as a phase modulation. These three are under continuous wave modulation techniques. Nothing but observe the key points. The message signal and carrier signal, both the shapes are continuous in nature. When you combining these two, message signal and carrier, we are observing the modulated signal with respect to instantaneous value. That value should be amplitude. It is called as a amplitude modulation. That value should be frequency. It is called as a frequency modulation. That value is phase. It is called as a phase modulation. These three under continuous wave modulation techniques. Then go for what is the difference between analog modulation and digital modulation techniques. What is the difference between analog modulation and digital modulation techniques? Observe here, the analog modulation and digital modulation techniques. Remember, just observe here, AM, FM and PM. These three are analog modulation technique. Observe the digital modulation techniques here, PCM, DM, ADM, DPCM. PCM means pulse code modulation, DM means delta modulation, ADM means adaptive delta modulation, and differential pulse code modulation. These three are different types of digital modulation techniques. In the coming sessions, we are discussing one by one very clearly what are the generation methods of analog modulation techniques. These things are we discuss in the coming sessions. Right now, what we discuss in the session is analog modulation. In the analog modulation, we discuss the three different modulation schemes: AM, FM and PM. AM is amplitude modulation, FM is frequency modulation and PM is phase modulation techniques. And observe the previous comparison because it's already explained actually, but one more time I will repeat here. The modulating signal should be in analog, but in the case of it is a digital. Here the amplitude, phase or frequency should be varying, nothing but as per the definition. The amplitude is varying, amplitude modulation. Frequency of the carrier is varying, means frequency modulation. Phase of the carrier is varying, nothing but phase modulation. Here amplitude, width or position of the transmitted pulses is constant. Okay, that is the difference between. But here once we observe the noise levels, the noise immunity is poor for AM but improved for FM and PM technique. By following some probability mechanisms, we are reducing some noise immunity levels. The noise immunity is excellent because it is the digital modulation techniques. We have different coding techniques we had, then we are reducing the error, then the efficiency will be more in the case of digital modulation technique. And next one is, it is not possible to separate out noise and signal, therefore repeaters cannot be used. That means the complexity is more between the transmitter and the receiver. Due to the analog processing, it is a continuous, therefore efficiency is low comparing with the digital modulation scheme. The next one is, coding is not possible. Next one is, bandwidth is required is lower than that of digital modulation techniques based on the frequency. It is a continuous. therefore complex to measure or to maintain the bandwidth. Here, FDM is used for multiplexing in the case of analog modulation scheme or analog communication. TDM is used for multiplexing. Next one, not suitable for transmission of secret information in military applications because at the receiver to decrypt the information from the transmitter, it is little bit complex of the analog communication and analog modulation process. But when you are applying the coding in the digital communication or digital modulation schemes, it is very easy to decrypt the information. That's why analog modulation systems are AM, FM, PM, PAM, like this, PWM, like this. And here the digital modulation techniques are PCM, DM, ADM and DPCM. So one by one we will learn. Therefore, what we will discuss means, in the present class we discuss about the analog modulation schemes AM, FM and PM. Therefore, individually we discuss how the AM signal can be generated, what are the methods we have to generate the AM, what are the methods we have the generating FM, nothing but a modulation and a demodulation process. Generation is nothing but how you can generate the amplitude modulated wave. What are the techniques we have, that is called amplitude modulation generation methods. In the next topic, we discuss about the generation of AM. Thank you very much.